Overview of emissions inventories. What is an emissions inventory and why do we need one? An emissions inventory is basically a list of sources and the pollutants they emit that can affect the air quality on your land. This workshop, Emissions Inventory Fundamentals, we're going to go over the types of emissions inventories, types of pollutants and source type categories, and as we talked about in the first webinar, the outcome is going to be a level 4, which is a list of sources and the pollutants they emit that can affect the air quality on your land. The next workshop, Emissions Inventory Advanced, is when we get into TICE more in depth, and we use emissions factors to actually calculate emissions based upon activity information that you gather, such as the number of gallons of gas that are pumped from a gas station. An emissions inventory is basically a snapshot in time. So over a year period is the usual time period, and for a specific area, and that could include a buffer zone outside your tribal boundary, because obviously sources outside the tribal boundary affect the air quality over the tribal land. So you may want to look at 10-mile buffer zone, 20-mile buffer zone, 50-mile buffer zone, depending upon what kind of sources you've got, how far away they are, what the prevailing wind direction is, what the topography is. So in terms of the geographic area, that's something that's flexible, and you need to look at what is near you to decide on that. Again, the level 4 will basically have a list of sources, what source category they're in, and what pollutants they emit. If you produce a level 1, 2, or 3 emissions inventory, that's when you're using activity data to perform calculations. You can use emissions inventory information for a variety of purposes. It's usually considered the first building block of an air quality program, which makes sense if you think about it, because you want to understand why the air on your land is the way it is and how it got there, where these pollutants, if you have pollutants, are coming from. So it's often cited as a reason to collect emissions inventory data is to collect baseline data. So as the air quality changes, as new expressways are built, new developments come up, and the air quality changes because you've got new sources, how does that affect your air quality in terms of the air quality that you know you have today? So it's really important in terms of management strategies for your air quality program to have an emissions inventory in place at least for 1 year, and then perhaps every few years you can reassess it. It's important if you are working towards developing regulations. Obviously, the first step is to understand what sources there are in case you want to continue on and develop potentially permitting programs, for example. Air quality modeling and assessment, you can do some very easy, quick and dirty air quality modeling just using backward trajectories or something like that. If you know the locations of the sources, what pollutants they're emitting, you can actually use some of that information in terms of predicting the air quality. So again, permits, obviously you need to know what facilities there are, and as you move towards regulation development and developing a system of obtaining fees, you want to know what the emissions are. You want to compare that with emissions from similar type sources. So it gives you a greater understanding of the different activities that are going on that affect your environment. Criteria pollutants are defined a little bit differently for emissions inventories than for air quality monitoring. Criteria pollutants include the PM10, nitrogen oxide, sulfur dioxide, carbon monoxide, and lead. It does not include ozone, of course, because ozone is created on the fly from volatile organic compounds and ammonia. So what emissions inventories do is they inventory sources of these precursors. In addition, HAPs, also known as air toxics, these are over 187 carcinogenic compounds, and they don't have standards, but it's very important that we understand where they're coming from in the air. So again, ozone itself is not emitted, at least in great quantities, directly by sources. Instead, the VOCs in red and the nitrogen oxides in blue and orange are released from the sources. Then the sun starts shining on them and they react to form ozone. So basically the emissions inventory list of pollutants that we come up with is going to have estimates eventually of the precursors of ozone. The hazardous air pollutants or air toxics include some pretty bad stuff. Mercury, perchloroethylene, benzene from gasoline, chloroform, methyl isocyanate, which is a pesticide manufacturing potential emission. It killed 4,000 people at Bhopal, India, if you're old enough to remember that, like I am. And these air toxics can have some serious effects, so they're usually included. The sources are divided up into categories, and the first few times you go through this, it will seem the names are strange, but after a while you just get used to them. Event sources, that's fairly straightforward, and you can see the arrows pointing towards forest fires. Non-point sources, which used to be called area sources, include in this case a cluster of homes that probably are heating with wood smoke. So you might think like, well, each of these houses with its little chimney, isn't that a source? It is, but the easiest way to handle a lot of different types of emissions are as a non-point or an area source. And there's some flexibility. So there could be perhaps a gas station, and depending upon your situation and the easiest way to calculate the emissions from it, you may want to use that gas station in the category of non-point sources, like an area source. So there's some flexibility between non-point sources, which are spread out sources, and point sources. In this diagram, the arrows for point sources are going towards these stacks from these factories, which is how we usually think of point sources to be. Then there are the sources that move around. So those are sources that move around on the road, including trucks and motorcycles and cars, and then sources that move around not on a road, and those are called non-road mobile sources, and those include tractors. Snowmobiles can have a lot of emissions. So again, these are the general categories, and there is some flexibility, and we'll of course work with you on that, depending upon the easiest way, basically, for you to calculate emissions for some types of sources that might be either non-point or point. So the steps to develop your emissions inventory. The first step is to gather existing data for a lot of reasons. One is, of course, you don't want to reinvent the wheel and try to do calculations that have already been done. And the other is that it's important for you to understand what is already there to guide you, because you may want to gather source information from some of those facilities or do some estimations yourself, or you may find that this is sufficient. So basically, the National Emissions Inventory database has data that include emissions that have already been calculated by states, counties, and in some cases supplemented by EPA. That data has already been QA'd, EPA has reviewed it, and it identifies point sources that are in your area and that could affect your air quality, as well as non-point sources that create the most emissions in your area. So it's extremely educational, and it allows you to start with this as a fundamental building block in case you want to go on and continue and gather more information from these and perhaps additional sources that aren't already represented. So that will be the product of this workshop. And we encourage you to use the mock emissions inventory that Angelique wrote. as an example for your emissions inventory, the mock emissions inventory includes the categories point, non-point, non-road, on-road, as we already discussed, and includes the NEI data, that's real data that Angelique downloaded for this particular part of Arizona. We haven't talked about quality assurance project plans. That's because for a level 4, you really don't need an extensive QAPP if you need one at all, and that would be something that your regional office would let you know about. It's important to, no matter what, document where you got the information, document the different steps that you use, and in case that documentation has to be formalized in a QAPP, according to your EPA regional office, I have an example QAPP that corresponds to the mock emissions inventory, and you can use that QAPP example for your own. Now, when you go on, if you go on to write a level 3 or a level 2 emissions inventory, then your QAPP would have to be a little bit more extensive, because that means you're going to be going out and gathering source data, like the number of cars that traverse this road, the number of gallons of gas that are pumped by this gas station. And so you're going to be gathering data, and so you need to have quality control procedures in place so that you know that the data you gather is going to meet your needs. Again, we've got stationary sources, which are point sources. We've got stationary sources, which are more spread out. Used to be called area sources and now are called non-point sources. Events, like fires. Mobile sources on the road and not on the road. And biogenic sources. Biogenic sources are those that are there without any activity by humans. So it wouldn't be alfalfa fields, it wouldn't be cows, because those are only there because we've put them there. It would be forests, methane swamps. What is a point source? We're going to get into these definitions of these source type categories. It's an individual stationary source, and it emits quantities above the emission threshold for a point source. This gets a little bit confusing, but there are definitions for what a point source is in terms of it has to be big enough to emit pollutants all by itself so that it can be counted as a point source. Now, what makes it complicated is that emission thresholds vary according to the type of pollutant and where you are. If you're in a non-attainment area, there's going to probably be more reporting that EPA wants from a non-attainment area. So EPA has the air emission reporting requirement rules that give thresholds for what is a big enough source to count as a point source. So the federal reporting thresholds are pretty high. Many states have lower thresholds, and it's important for you, if you remember, one of the data quality indicators is comparability, right? So you want your emissions inventory to be comparable to other emissions inventories, perhaps by other tribes, perhaps by the county, so that you can compare apples to apples or oranges to oranges. But you want to probably use the same definitions as the emissions inventory in your area. So, for example, a busy gas station, like a really big truck stop like this, could be classified as a point source under the state thresholds, but not EPA's. According to EPA's definition, it would be an area source and just get lumped in with all the other gas stations in the area. So let's look at what these thresholds are. So this is just an example. This is the state threshold, the New Mexico state threshold for what's big enough to count as a point source. You can see that New Mexico says, hey, you emit more than 10 tons per year of VOCs or carbon monoxide, and we want you reporting as a point source. We want those calculations just for you. Whereas EPA says you have to be gigantic. You have to be emitting more than 1,000 tons of carbon monoxide for us to care about you as an individual point. So this is where this confusion comes in as to what is a point source. Again, they don't move around. We've got that about point sources. They tend to be larger plants, And they tend to probably have multiple emissions points, maybe multiple stacks. You've got different processes going on in there. You've got things going through vents to different emission points. And pretty much always you've got fugitive sources, which is the stuff that just comes out. A lot of times it's particulate matter, and it is released all over the plant. Non-point sources, again, less than the point source threshold, so they tend to be smaller emitters, but they can be numerous. Many intersections have a gas station on all four corners, for example, and they often have these uncontrollable fugitive emissions. And I think everybody's familiar with the different kinds of experiments that EPA has imposed upon gas stations in terms of catching the gas that comes out as vapor, and that would be an example of a fugitive emission. So gas stations tend to be non-point sources, dry cleaners, auto body paint shops, unpaved roads. That's a big, very common example of a non-point source for PM. Agricultural field burning, residential wood stoves, and burn barrels are typical examples of non-point sources. Event sources, fires is the only event that usually comes up. We don't have a lot of exploding volcanoes, but these are classified as events. On-road mobile sources, again, they emit a lot of VOCs, and especially important to EPA are some of the air toxics that are qualified as urban air toxics that are particularly important for environmental justice questions, because a lot of times expressways go through lower income areas, and of course that's where the most pollution is, and they're particularly interested in these urban air toxics. Diesel gas, these are also quantified from on-road mobile sources. Really stinky things we drive around in. Non-road mobile sources, one of the biggest ones is snowmobiles. That's a big example of a non-road mobile source. Farm machinery. An exception that is kind of non-intuitive are commercial marine vessels and locomotives are usually non-point sources. And aircraft, surprisingly enough, are now classified as point sources being located at the airport. So again, this is something relatively new. Most NEI data already has aircraft emissions already quantified. It may be that you've got a small airport and you have more accurate data in terms of the number of takeoffs and landings, but probably not, in which case you could just use the NEI data. So, biogenic sources. Biogenic sources are emitted from sources that are there no matter what humans do. So forests, grasslands, termites apparently emit a lot of gas, and EPA estimates these emissions on a county level. So people, even states and counties, don't calculate the emissions from their biogenic sources. At least they don't have to in terms of reporting to EPA, because EPA already does these calculations. So at this point, you're probably feeling like this dog. I know I am. And so we are going to take a fun little quiz. Woo!